Okay, thank you. So this is the same problem what we discussed last class. So you have a simply supported beam having a point load at the center. Okay, so we know what is your boundary condition. When x is 0, u is 0, so y is 0, and when x is L and y is 0. So at the midpoint, when x is equal to L by 2, you know that your y will be a maximum, right? Your deflection will be maximum center. So we last class we tried to solve this problem by using two terms. So one by using a polynomial term, which is a naught plus a1x plus a2x square. The second one is we use a trigonometrical series, something like a1 sine pi x by L, right? And we also consider only one term, not more than that. Okay. So this problem deals with two terms in trigonometric series. Okay. So I suggest you not to consider this problem if they are not mentioned anything as a two term. Okay. So you can able to see the problem is same. So in the question, they are not indicating anything that what type of series you have to take or what type of terms you are going to take. Okay. In that case, you always prefer one term trigonometrical series. Don't go for two. So because it is complicated, you can able to see when you solve this problem, right? So I'm going to display it. So let us consider two approximation functions. Let me consider y is equal to a1 sine pi x by L plus a2 sine 3 pi x by L, right? These are my two terms. So when I substitute x is equal to 0, so I'm going to apply what is my boundary condition. So for this two cases, so when I consider x is equal to 0, your y should be equal to 0. Substitute it, so sine 0 becomes 0. This is also 0, 0. Okay, it is satisfying. What about when I substitute x is equal to L? Right? When I substitute x is equal to L, you are getting sine pi. And here you are getting sine 3 pi. Again, so the sine pi and sine 3 pi, that is also is 0. So again, y is 0. So it is satisfying the boundary condition. So no need to change your trial function. You can use that as a regular trial function, right? Now, we apply potential energy. So according to total potential energy, pi p is equal to u minus w, where u is your strain energy and w is your work done. So what is your u? So you know the formula. Ei by 2 integral 0 to n d square y by dx square the whole square into dx. So what I have to do? I have to differentiate this y twice, right? So and then I have to substitute in this strain energy equation. So differentiating one time, you are getting a1 phi by L cos pi x by L plus a2 3 pi by L. So as we discussed earlier, same thing, right? We are having a term like this. Okay. So next differentiating again, you are getting one more term, which is adding multiplied with that. So you will get overall a function. So what is your function? Your d square y by dx square will be equal to minus a1 of pi square by L square sine pi x by L minus a2 of 9 pi square by L square sine 3 pi x by L. So this is my overall term. Okay. Now what you can do, you can to substitute this in our strain energy equation, right? So here comes the complication. What happens? It is like a plus b. It's a formula related to a plus b. So this has to be squared again. Okay, then you have to solve. So I'm going to square it. So this is my minus sign is a common term. I can take it out. So if I take that out, so remaining term, right? I have to square it again. When I square, so I am taking these things, whatever the common things, I am taking it out. So when I take out, be careful. So you have to take it out with the squares. So pi square by L square is a common term here. You can able to see. So this pi square by L square is common here and it is also common here. Okay. So this is squared actually. Right. So when I take it out, it has to be pi power 4 by L power 4. So remaining terms. Right. So now same, it is like a plus b the whole square formula. Apply it. You will get a whole term like this. Okay. So yeah, sine square of these things a square plus b square plus 2ab. Right? This is the thing you are getting here. Now I have to integrate these things. Okay, see the complications, right? So let me consider the first term. So a1 square sine square pi x by I. Right, as we discussed earlier, so you can't integrate the sine square. What you have to do, I have to convert it, right? Convert it in terms of cos 2 theta formula. So we are applying that. So I'm going to consider this integration alone separately. So when I convert it into cos 2 theta, right? So as we discussed here, so cos 2 theta is equal to 1 minus 2 sine square theta, right? So you can substitute sine square theta will be equal to 1 minus cos 2 theta. So this is 2 theta, okay? Cos 2 theta divided by 2. So this is what we are getting here, right? Pi x by L will be 2 pi x by L. So 1 minus whatever the term you are getting, right? Here also a1 square is a common term, taking it out. This alone, I'm going to integrate it. When I integrate, I get a term. So overall, applying the limit. So you will get a1 square L by 2. So now I'm going to consider the other term. So a1 square, that one. Again, I have to convert it in terms of cos 2 theta. So I'm getting like this 81 a2 square by 2, the remaining term. Integrate this. So apply your limit. Then you will get another equation, which is 81 a2 square L by 2. Right? This is my second term. Okay, this 2 is over. Next, third term. So third term, you can able to see that it is like sine pi x by L, sine 3 pi x by L. Right? Sine A, sine B. Right? It is like sine A, sine B. You have to use the formula accordingly. Right? So trigonometric, there are some formulas related to the cos A plus B minus cos A minus B. Right? That formula. Right? I'm going to take this. You know that. So cos A minus B minus cos A plus B divided by 2 will be equal to sin A sin B. So it is like this actually. The formula is cos A plus B minus cos A minus B is equal to minus 2. This is the formula. So this is what it is relocated and you are getting some formula like this. Okay. What is my A? A is pi x by L. This is my A. So what is my B? So this is my B. Okay. So I am going to substitute it accordingly. And we can, of course, you can also change it. So you can also consider this as A or B, whatever it is. We can do that. So you substitute it accordingly. So you get another equation, right? This equation, you integrate it, right? So when you apply the limit, at the end, it becomes 0, right? So this entire term becomes 0. Okay, so because whatever you substitute the limit, your sign of 0. So you'll get sine 0, sine 2 pi, whatever it is, everything is 0. We know that sine n pi is 0, right? So in that case, no need to worry about it. So the entire term is 0. So now I can able to conclude what is my strain energy equation, right? My strain energy equation is EI pi power 4 divided by 4 L square L cube A1 square plus 81 A2 square. So this is my overall strain energy equation. Okay, this part is over. Let us go for work done. What is our work done? So you have a point load only at the center. In that case, your x has to be substituted as L by 2. So this is my y term. So a1 sin pi x by L plus a2 sin 3 pi x by L. Substitute x is equal to L by 2. Right? So what will get? So when I substitute x is equal to L by 2 here, so sin pi, right? You will get sin pi. Here you will get sin 3 pi. Right? In that case, so what will be the term? So sin pi. Sorry, it is not sin pi, right? It is sin pi by 2. Sorry. Sin pi by 2. And this is sin 3 pi by 2. Okay. So sin pi by 2 is 1. So which means I'll get only a1. So sin 3 by 2 is minus 1. So I'll get minus a, minus a2. So this is my W work done. So now I can identify what is my potential energy equation. This is my potential energy equation, right? Okay, this part is over. So how many constants are here now? Yeah, you have two constants. One is A1, another is A2, right? So which means I have to partially differentiate with these two constants and you have to equate it to 0. So first, so dou phi p by dou A1 is equal to 0. And of course, the second constant is dou phi p by dou A2 is equal to 0. First, let us consider dou phi p by dou A1 and equate it to 0, right? So the first one, dou phi p by dou A1 is equal to 0. So what we'll get, this is a common term. You can write it A1 square. If we differentiate, you'll get 2A1. And this will be minus W, right? So this is my term after you apply a limit. So now you can able to see that you can able to identify what is the value of A1. So A1 is this, right? Next, dou phi by dou A2 is equal to 0. Equate it. So again, so this is the common term. So 81 into 2A2 and this will be plus W, right? So that is the entire term. So minus the plus W. So again, I identify what is my A2 here, right? So this is my A1 and this is my A2. So now you substitute these things in your equation. That is my final equation, right? This is my final answer. Okay. Okay. So let us check it out. Let us check it out. So by substituting x is equal to L by 2, right? What happens for this equation, right? So, okay. So let me substitute x is equal to L by 2. So in this, if I substitute x is equal to L by 2, what you'll get? You will get y is equal to 2L cube W divided by EI pi power 4. Okay, common term. This is L by 2. So L by 2, if I substitute, I will get sine pi by 2, which is 1. Okay, minus 2L cube W divided by 81 EI pi power 4 L by 2. So you are getting 3 pi by 2. 3 pi by 2 is minus 1. So it becomes plus 1 here. This is plus. So which means what are the common terms here? I will take the common terms outside. So WL cube by EI. I will take it out. Right? WL cube by EI. So what will the term? I will get it 2 by pi power 4 plus 2 by 81 pi power 4. Right? Now use your calculator. Find out what is the value here. Okay, you are getting around 1 by 48.1. Okay. So WL cube by 48.1 EI. Right? So I think what we achieved previous class.
48.6.
48.6, yes. So we achieved around 48.6, right? So whereas here, yeah, it is little bit more, a little bit closer, right? So answer is 48. So you are getting a little bit closer. So this is the problem. Let me consider here. Just look after here. So what is the purpose of this equation for this problem? What is the purpose? When Rayleigh's Ritz, our importance is to be based on your strain energy. It purely relates on strain energy equation, right? So actually, this is also not a strain energy. This is your potential energy equation, right? Overall, so phi p, right? Actually, this is potential energy, right? Purely depends on this potential energy, right? So there is no relation between this and this. Okay, no relation. But this is related to weighted method, weighted residual methods to identify your residual. Okay. Whenever the same question can be asked for weighted residual method also. Right? Don't get confused. So இதை எடுத்துட்டேன்னு வச்சுக்கோங்க. Right? If I remove that, you can solve in any method. Either it's a Rayleigh's method or in a weighted residual method, you can solve in any of this method. Okay. So it won't affect. So for weighted residual method, you need this equation. This is not required. Right? So for Rayleigh's method, this is required. That is not required. So it is a common question which is asked for both the cases, right? So that's the importance of this particular problem. So sometimes they will ask us weighted residual also. Okay, right. So they are given what is the trial function. So my trial function y is equal to ax of 1 minus x cube. Okay. So first let us check it out whether it satisfies the boundary condition. When x is equal to 0, y has to be equal to 0. Substitute it. Yes, it is 0. When x is equal to 1, y is equal to 0. So based on this. Okay, when x is equal to 1, y is equal to 0. Substitute it. Yeah, it is also satisfying. So no need to change your tail function. This is my tail function. Okay. Now what I do, I have to apply this tail function in this potential energy equation. Right? So they are given I. So I is equal to integral 0 to L. Okay. So minus 1 by 2 dy by dx the whole square plus 300 x square y. So this is my term. In this, just look here. So your y is here and here. So I have to apply this equation in these two cases. Okay, so for that I have to differentiate once. So let me identify what is dy by dx. So dy by dx will be equal to, I will first, sorry, before that I will write what is my y by taking it inside. So I'll get ax minus a into x minus x power 4. Right, bringing this x inside. Now differentiate this, what will get a into 1 minus 4x cube. Okay, now let me substitute it here in your I function. So I is equal to integral 0 to L minus 1 by 2, right? So this one is A into 1 minus 4x cube the whole square plus 300 x square into y, right? A into x minus x power 4, right? This we have to integrate it. Okay, so now let me substitute. What is your I value here? So I value is integral 0 to L, right? So this is minus 1 by 2 a square, right? That I will take it out. Remaining term is 1 minus 4ax cube the whole square, right? So I will expand it. So 1 minus 4 4s are 16, 16x power 6 minus, sorry, plus 16x power 6 minus 2ab. So 2 into 4x cube, right? This term plus 300a as a common term. This x square I am bringing it inside. So we'll get x cube minus x power 6. Right? This is my term. Okay, let me integrate it. So minus 1 a square by 2. That is a common term. I will take it out. Integrating this 1. Integrating, I will get x plus 16 x square. Integrating, I will get x power 7 by 7 minus 4 2s are 8 x power 4 by 4. The limit is 0 to L. 1 or L, sorry, I got confused. Actually, it is 0 to 1, right? Because my limit is 0 to 1, right? So I entering, maybe it's mistaken. Right, so okay, I'll change it to 1. It is 0 to 1. My limit is 0 to 1, so it has to be 0 to 1. Okay, so change it accordingly. This is 1. This also 1. This also 1. So when I apply the limit, it will be from 0 to 1 plus 300a is common term. I will take it out. So this integrating x square x cube x power 4 by 4 minus x power 7 by 7. The limit is 0 to 1. So just apply it. So we'll get is equal to minus a square by 2 1 plus 16 by 7 minus 2, right? After applying the limit, plus 300 a 1 by 4 minus 1 by 7. Okay. So what are the terms you are getting here? First term. So plus 300 a into 3 by 28. Okay, thank you. Right. So this is my values. So which means again I can redo this. Will get us 9 minus 9 by 14 a square plus so 900 by 28 a. It will be like this. This is my I value. So now you have only one constant here. According to Ritz method, we can do dou I by dou a and I can equate it to 0. Right? In that case, what I'll get? I'll get minus 9 by 14 into 2a plus 9 and by 28 is equal to 0. So what is the value of a? Okay, you are getting a as 25. Right. So a is equal to 25. Right. So now I got what is the value of a, right? Substitute it in your equation. That's it. What is my equation? The equation is y is equal to ax of 1 minus x cube, right? So which means y is equal to 25x of 1 minus x cube, right? This is the answer. I will give a hint how to solve a problem when you have a cantilever beam. Okay. So let me consider you have a beam like this, right? So something like this, in which one end is fixed, other end is free, right? So here what happens is this end, this end is fixed, right? So now you have a load of W at this point. So WL, right? This is a cantilever beam, right? So previously, for a simply supported beam, we consider an equation. What is the equation? We consider y is equal to a1 sine pi x by l. This is what we consider, right? So you can't use this particular equation for this cantilever beams. Why? It is not satisfying. So it won't satisfy the boundary condition. So according to simply supported beam, when x is 0, y is 0. So my equation for simply supported beam will be like this. This is my equation. When x is 0, y is 0. This is one boundary condition, right? This is one boundary condition. The other boundary condition, when x is L, y is 0. This is the condition. But if you go for a cantilever, it is different. Here, what happens? Where x is here, when x is 0 and x is L here, right? So I can say that when x is equal to 0, right, y is 0. That is satisfying. Very good. But when x is equal to L, your y should not be equal to 0, because at that point you will have a maximum deflection, right, for a cantilever. So in that case, if I substitute x is equal to L here, what happens? It becomes 0, which means this equation is not capable to solve cantilever beams. Okay. For cantilever beam, there is a separate equation. So what is that equation? So y is equal to a1 of 1 minus cos pi x by 2l. This is the formula. This is the formula. Okay. So for any cantilever beam, you have to use this as a trial function, right? So for cantilever beam, for any cantilever beam, you use this as a trail function.